many kilometers beneath the moon's surface, all is silent. Without liquid water or plate tectonics, the quiet is broken only every so often by a tremulous rumble. For the best part of 700 million years since formation in the fires of planetary collision, little has changed. This slice of the moon's crust has lain dormant. Until now. With the power of more than 10 billion nuclear bombs, its safe haven is atomized in seconds, and it finds itself flung up into the maelstrom yet again. The surface of its old home, devastated and retreating from its vision, is sloshing about in towering, dusty breakers. The moon has suffered a massive impact. The new traveller arcs effortlessly across the sky, accompanied by a tsunami of ejected material, a diaspora. Beneath, the surface of the moon scans past. It is grey and cratered and dead. The gale of displaced rock lands like a plague, all at once and suffocating, fusing together into one solid mass of stone on the monochrome plane. From its new vantage point on the exposed surface, the recent arrival watches its new neighbour. It is also under siege. Disparate craters splash matter across the young Earth's chaotic exterior. It whips around with impatient futility, immobile, defenceless against the bruising circles appearing again and again on the surface. As millennia pass, Earth changes colour periodically. Reds turn to blacks, blues sprout rushes of green. Ice comes and goes, the circles of destruction still appearing on occasion. Mostly, though, it just shrinks. It has been retreating for eons, and so is very small now. But recently, something very odd has occurred. It has blossomed. Only visible when the Earth is black, tiny lights have begun to pepper the planet, spreading in white veins across its surface. And this is when, after 4 billion years of detached, lonely observation, our traveller is finally met by another.
11 forward, coming down nicely, 200 feet, 4.5 down, 5.5 down.
Back on Earth, the myriad lunar samples from the Apollo missions were carefully studied. For the first, and to date only time, scientists had access to matter harvested directly from another world. With so many mysteries to unravel, answers were now potentially within reach, and to the delight of Earth's scientific community, this newfound data converged upon an insoluble truth. Gouged upon the lunar tissue rested the scars of a tremendous calamity. Inside the materials, atoms providing substance, form and identity had been shocked into a heightened alignment. Crushing pressures had coerced the rock into metamorphosis. An Armageddon was fossilized on the moon. But, of course, evidence of stellar impacts had been expected. Galileo Galilei first recognized the lunar craters back in 1609, and in preparation for their missions, Apollo astronauts were trained to spot the signs of impact. Looking at the moon through a telescope reveals gaping excavations, hundreds of kilometers across, and bands of wreckage slung even further. Explosions that punctured deep, leaving pools of magma to burble. In truth, evidence of massive impacts surprised few. What shocked the world was the age of that evidence. Locked inside metamorphosed minerals and inside the rocks, liquefied by each calamitous strike, lingered atoms edging towards disintegration. By measuring and comparing these unstable elements and their offspring, samples from the Imbrium crater, the highlands, the Sea of Serenity, samples collected 1,000 kilometers apart or more, we acquired an age. The same age, over and over. 3.9 billion years old. What catastrophe could have so traumatically reshaped the moon? Not a single impact, but a throng, a flood, a bombardment, each diving body dozens of kilometers across. But if a swarm of celestial invaders assaulted the moon, what then of its more massive partner? What happened to the Earth? Modelling and the geological record show that for every collision suffered by the moon, the Earth endures 20 of its own. Such a disaster would have remade our planet, momentously diverting it to a new evolution. Whatever traumatic effect this cataclysm had upon the Earth 3.9 billion years ago, its earthly evidence has long since been buried, eroded, melted, and dissolved. If we want to know what happened on our planet 3.9 billion years ago, we must look towards the rest of the solar system. For 5 decades, experts have scoured their imaginations and scientific data for the origins of this catastrophe. Did a 5th terrestrial planet disintegrate, spraying its minerals across the solar neighbourhood? Did a clash near Mars divert a string of projectiles in our direction? Many different causes were proposed, but scientists settled upon one main hypothesis. If Jupiter's orbit was altered due to some catastrophe in the outer disk, then a rabble of remnants from the early days of accretion could have been ousted from their homes and condemned to a brief and desperate exodus. If this descent did take place, then evidence is just as likely to be found on our neighbours as on our Earth. The baked surface of Mercury is pocked by a graveyard. The same travellers that scarred the moon also dug great graves on Mercury, and Mercury buried them in magma. When the largest meteors crushed into the feeble surface, they thrust and hurled enormous masses of stone away from their resting place, leaving punctures in the crust hundreds of kilometers across. Into these gouges rushed the pressurized mantle. Superheated and relieved of its confinement, the surging mantle melted and exuded through vast vents on the surface. Layer upon layer of hardened magma built until the cavities were filled with kilometers of basalt. The most destructive meteors to strike Mercury didn't just melt the crust, but jump-started an era of regional volcanism that shaped the planet over hundreds of millions of years. The moon, too, was likely provoked into volcanism by its bombardment, thus producing its famous seas. At the Imbrium Basin, the elected landing site of Apollos 14 and 15, a hardened ocean of basalt swamps the crater, drowning a ring of islands denoting the crater's rim. Immense fields of basaltic flows would have dominated the Earth's surface, too, 70 to 100% of it smothered by this blanket of igneous rock. Beneath the crust, the decompressing mantles surged and seethed, swelling at the basin, causing the weakened crust to bend, buckle, and slip beneath into the underlying turbulence. The thin plate is dragged across the surface and into the depths and is replaced with new crust erupting from the vents. These episodes of ephemeral subduction last no more than 10 million years, but they may have instigated the modern phase of plate tectonics. On the surface of Mars, too, we see the results of destructive visitors. Across the southern hemisphere, the highlands break suddenly into yawning cavities with distant rims. In the north, though, are quiet, endless plains devoid of landmarks. The contrast between the north and south is stark and perplexing. For many years, scientists pondered this enigma until detailed topographic mapping revealed a titanic ellipse, the relic of a colossal crater covering 42% of the planet. So large as to be almost invisible. The Borealis Basin. This could mean only one thing. In the deep past, a planetoid nearly the size of Pluto hurtled into the North Pole, atomizing itself along with much of the planet. As Theia struck Earth, so this giant hit Mars. The explosion exhumed half of the Martian crust, ploughing it southward in a rolling deluge that entombed the rest of the planet in drifts of rubble, possibly 30 kilometers deep. It is likely that the Earth was struck by several Borealis-level impacts of its own. It was inundated with meteors, at least 100,000 of which left a crater 20 kilometers across or larger. Some much larger. Around 3,000 are thought to have struck the surface, obliterating 25 times their surface area, atomizing and liquefying awful chasms into the crust. Hundreds of meters of ejected material would have swamped the planet, commingling with the sheets of basalt, the Earth churning beneath the chaos. Under this deluge, Earth's primordial atmosphere would have been asphyxiated by vaporized rock, condensing into blazing droplets of molten rain. A global storm of cinders, the heat of which boiled away ancient seas. The planet would have baked in unendurable heat, sterilizing the surface. If the first saplings of life survived this apocalypse, it would have done so hidden within hydrothermal systems, veins of superheated mineralized fluids jetting between fractures deep inside the hellish world. But the Borealis Basin formed 4.47 billion years ago, long before the era of lunar bombardment. Mercury, the Moon, and Mars, all pockmarked and pitted by the passage of those unfortunate bodies that collapsed onto the Earth. However, Mercury, the Moon, and Mars are unlike Earth in many ways. They are small bodies with little atmosphere and limited geologic activity. They are breathless and still. But Venus is akin to Earth, a living planet comparable in size and closest in its orbit to ours, and like the Earth, Venus is still evolving. But also, like the Earth, its past experiences are shrouded deep within layers of elemental cloud. And as yet, we can glean no answers. Testament from the asteroid belt further muddies the chronology, a bevy of interasteroid impacts between 4.1 and 3.5 billion years ago. Could this disruption in the belt reflect the origin of the bombardment or its passing through? How can we square this 600 million year period with the history of lunar bombardment, a sixth as long? What evidence the Earth can provide tells a similarly confusing story. Beds of beads, stone raindrops birthed from the asphyxiated atmosphere after a major impact, are common as late as 3.5 billion years ago. It's clear that the terrestrial planets were brutally pounded. The question, though, that is now being asked is when. Attempts to date the other titanic impact basins of Mars and Mercury output ages that corroborate the lunar record, around 3.8 to 4.1 billion years. But these dates are based on models tied to the same Apollo samples that first revealed the late heavy bombardment. The theory therefore balances precariously on the reliability of a handful of lunar samples, collected half a century ago. So far, we have sent 6 Apollo missions to the Moon. Just 12 travelers making steps on the surface of another world. 3 of those missions, Apollos 14, 16 and 17, returned samples that record evidence of late heavy bombardment. The furthest distance between these 3 landing sites, indeed the furthest distance between any 2 Apollo missions, is only 1,607 kilometers, barely further than the distance between the Apollo astronauts' training facilities in Houston, Texas, and where they landed at Kennedy Space Center in Florida. Though limited by practicalities, scientists had selected these sites for the differences in their cratering. Apollo 14 at Imbrium Basin, Apollo 17 at Serenitatis Basin, and Apollo 16 at a heavily cratered highland region. In the 50 years since, we have trained our eyes, mechanical and organic, upon these assumptions. CRISPR imaging of the outcrops sampled by Apollo 16 shows that rather than originating from local craters, the stones in question flew 1,000 kilometers from the Imbrium impact. A diaspora. Worse, chemical evidence of the Apollo 17 samples suggests they too emigrated from the same Imbrium basin. Indeed, one way to create an unexpected anomaly is to accidentally date the same event 3 times. The eager scientists of the 1970s failed to imagine just how far the influence of a catastrophic collision could spread. In recent years, these time-stretching revelations have destabilized the theory of the late heavy bombardment. The end of the bombardment is clearest. Evidence shows that it tapered off between 3.8 and 3.5 billion years ago. By the Earth's billionth anniversary, the bombardment had abated. The solar system was finally mollified. The beginning of the bombardment, however, retains its mystery. Though there is little doubt among scientists that Jupiter was the cause, the date of this event still eludes them. Some suggest a chilling explanation, one that has been lurking on the peripheries of the scientific discussions since the 70s. What if the glimpse we have of this catastrophe is too scant? What if we have only spied its shadow? The tortured minerals scattered across the solar system tell us their most recent trauma, but they have forgotten their deep past, their crystalline memories wiped. Impacts devour, digest, remake. Is it possible that buried beneath the lunar surface is a brutal history, clawing all the way back to Theia, to Genesis? Not a brief apocalypse, no calm before the storm, simply storm all the way down. So deeply buried, we cannot yet peer through to it. Scrambling for reliable physical evidence, scientists are coming to the conclusion that this bombardment may well not have been late, or indeed heavy, but a constant battering, lasting eons. In 2024, for the first time in 50 years, NASA intends to land astronauts once more on the Moon, this time at the lunar South Pole. Will they find evidence to corroborate the late heavy bombardment, or to disprove it? Rocks showing the same timestamp as those first examined 50 years ago? Or a new, brutal, billion-year time span? What earth-shattering revelations will be revealed this time around? Next time, we dive deep into the first oceans of our world. We investigate the tremendous tectonic forces that reshaped and made the Earth. And finally, still billions of years in the primordial past, the very first saplings of life. You've been watching the entire history of the Earth. Don't forget to like, subscribe and share, and let us know in the comments what you'd like to see covered in the future. Thanks for watching, and we'll see you next time.